Yes, hello friends. This is continuation of the stoichiometric and non-stoichiometric defects. Stoichiometric defects already last class we are completed, like short-key defect, Frank-Gehlen defect, or interstitial defects. Now we are moving to the second part of the defect, which we are called as a non-stoichiometric defect. In the case of non-stoichiometric defect, actually, the defect is discussed so far not disturbing the stoichiometry of the crystalline substance. That means the stoichiometric formula does not going to disturb by this defect. Such defects are known as the non-stoichiometric defect. But there are large number of non-stoichiometric defects will be there, which contain the constituent elements in non-stoichiometric ratio due to defects in their crystal structure. There are two types of non-stoichiometric defects. That means I want to tell you one more time, these defects are going to change the stoichiometry. Okay, whatever we discuss in the stoichiometric defect, they are not going to disturb the stoichiometry, but the defect coming under non-stoichiometry are going to change the stoichiometry. There are two types which are there. They are metal excess defect and metal deficiency defect. In the case of metal excess defect only, last class we are having a small section will be there regarding metal excess defect due to anionic vacancy. That time I told you, like the sodium chloride crystal is heated in the atmosphere of sodium vapor, then that sodium crystals are going to deposit on the surface of sodium chloride, then chlorine from the bulk medium is going to combine with the sodium, and the chlorine place become vacant. For maintaining the neutrality, the electron released from sodium chloride which formed at the surface of the crystal will be come to the place of Cl minus ion, and that vacant space occupied by free electron is called F center. This F center is the reason for formation of many colored compounds, like in the case of sodium chloride it impart yellow color after some time, and same way for lithium chloride it produce a pink color, and the excess of potassium in potassium chloride crystal makes violet color. Such type of coloration is forming in the crystal due to this F center. So this is actually they are asking for one mark type question, what is the reason for the coloration like that. So you have to know that is known as the F center. Then second category under metal excess defect is that is due to the presence of extra cation. Here they are explained with an example of zinc oxide. When we are heating zinc oxide, it is converting to Zn2 plus half O2 plus 2 electron. This electron oxygen is going outside, and which is to be maintained by the presence of two free electrons. So electrical neutrality is maintained here also. So what is happening, by removal of oxygen from the crystal, there is excess number of zinc ions will be producing, and that the formula, stoichiometric formula, becomes Zn1 plus XO. That is why the stoichiometry is going to be changed, and that is due to the presence of extra cation, that is zinc 2 plus ion is excess here. That is the second category coming under metal excess. In the first case they are having anionic vacancy, that is the F center. In second case metal excess, both are metal excess only, but in second case it is due to the presence of extra cations. Then third one, or the second category under non-stoichiometry, is the metal deficiency defect. In this case, there are many solids which are difficult to prepare in the stoichiometric composition and contain less amount of the metal as compared to the stoichiometric proportion. For example, iron oxide FeO. In the case of FeO, if it is in +2 state, ferrous state, then some of the ions will be oxidizing to ferric form also, Fe3+. So what will happening? Suppose one Fe2+ is missing from the lattice point, that two charges will be maintained by oxidation of adjacent 2 Fe2+ into Fe3+. So charge is maintained but one Fe is missing. That type of defect is known as the metal deficiency defect. So these are the two types under non-stoichiometric. They are metal excess defect and metal deficiency defect. Under metal excess defect you are having two types, anionic vacancy or cationic extra cations. So these both categories are coming under non-stoichiometric defect, which is going to change the stoichiometry. So defects of crystals are over. Next we are going to the electrical properties, which will be in the next video.